Hello, hi everyone. Thanks for joining us today. This is our seventh episode of the Everything Product series. Uh, Today we have a very insightful session ahead of us on heterogeneous network management. This is with our architect Manuela Canade. Manuela, thanks for joining us. I'll just quickly introduce her. She works at GS Lab Gavs as a software architect. She's leading several development projects, specifically in network automation. Brings a lot of experience, 14 plus years of experience in cloud and networking domains. She has been with GS Lab Gavs for now 8+ years, prior to which she was working with Cisco Systems in San Jose, USA. And while working with Cisco, I'm happy to mention that she has got two patents to her name, two US patents. And she's an alumna of Carnegie Mellon University, a prestigious school, and she has surely made her mark. So very happy to have you today, Manuela. Thanks for joining.
Glad to be here.
Right. So before we get going, we would love to ask our audience a quick poll question. Yeah, we can flash the question now. If you want to get a sense of, are folks working in this area on any product idea or planning to do that soon? All right, let's see what. Great. So many of them are currently working. So good. So we are looking forward to a good session. Thanks, guys, for responding. So to get it going, right? So Manuela, we want to sort of help us set the context, right? What is network management? Why is it important? How do you look at it more from a, firstly a broader perspective, and then we'll delve into the details.
All right. So network management is basically configuring and monitoring networks. So to put it simply, network configuration is to configure your network devices so that you configure the protocols and properties and access control lists and policies so that all your network devices are working well together. Traffic is flowing through your network as expected. So that is where network configuration comes into picture. And the other aspect is network monitoring. So you are getting useful information or device state from each of these network devices and then correlating it or analyzing it further to be able to show some dashboards or monitor the network performance or monitor whether there are any issues in the network. So that is why network monitoring is also important. So these two things, configuration and monitoring, are a part of network management. There are some additional related things also, like automating the provisioning of your network devices, or having a fault tolerant network like I mentioned, or ensuring that you have high availability or good network performance and network speeds. So these are all related, but the key here is configuration and monitoring. And why network management is important is because originally networks were small and they were being configured manually. So you would go and have a set of commands for your network devices to be able to configure those protocols and ports and your traffic flows. And you had network topologies which you would ensure whether they are up and running. That also was being done manually. But as the networks grew larger and larger, they became more complex. So what I mean by complexity here is they became geographically dispersed as well. So you have a branch office and a head office. Maybe they are in two different states, or you have network devices which are from multiple vendors. So you have some switches and routers from Cisco, some others from Arista, and you have load balancers and firewalls from some other companies. You have many connected devices also. So that also gave rise to the complexity of network management. And the third thing was they became very dynamic also. So it is not anymore like you have n number of workstations and that's all that you have to manage with a couple of networking devices. You have many networking devices. You have Wi-Fi access points, you have mobile devices and laptops and all these servers and other endpoints that you have to manage with a network. So all of this has given rise to the complexity of network management, and that's why this is a very important topic. And it has been so for the last few decades. So there have been many efforts to create good network management protocols, good network management solutions and systems, which will give you a centralized way of visibility into your network, and also monitoring these networks. So that's why I think network management is a broad and important topic. All these networking companies are coming up with different solutions for each of these problems as well. So yeah, I think that summarizes it.
Makes sense. Are there also some industry consortiums or alliances which are trying to do this?
Yes, so there are many standards bodies also. So for the internet, you have this IETF, which is the Internet Engineering Task Force, and there are many others also. Like there are many open projects which are going on. So for there is ONAS, which is the Network Operating System related project, or there is OpenConfig, which we are speaking about, or there is Open Telemetry. So these are all related to networking or network management. So yes, there are many such present.
Good. And historically, to give a sense, and for my curiosity as well. So how far back does this go? And are you seeing sort of some of the types of applications sort of gathering steam?
Yeah, I mean, this goes back to few decades ago. So the first network management protocols might have come about sometime in the 70s or 80s, where even LANs and all these terms were new. So maybe it's been there since then, but I think certain types of applications are where you can actually analyze the data and give good visibility into the networks. So those are the ones which are more important, and also, as I had mentioned, where you can identify the faults and even correct them possibly in an automatic fashion. The other area which is relatively new, not very old, is network automation. So you are trying to provision the networks in an automated fashion, and with different solutions and protocols like Ansible and Puppet and Chef. And these are the ones that are able to bring up your networks. But there is a lot of network automation effort even in the testing area. So automating tests which check your network readiness, and we are even doing a few projects at GS Lab like that. So I think those are some of the key areas.
Makes sense. So you sort of mentioned complexity, right? So I think the size of the network is one type of or one dimension which makes it difficult, I guess.
Yeah.
So when we talk of large network and small networks, I mean, roughly, again, to paint a mental picture, is it in terms of number of devices, or how do you look at, or is there some sort of some range of number of devices?
Yeah, so we can talk about it in terms of number of connected devices and also the number of network devices. So if you have a small office, then that's a small LAN network. If you have a university campus, that's a campus network, a medium-sized network maybe, or slightly larger than that. And if you have a big enterprise company, then that's a large network. So where you have a lot of networking devices also, and you have a lot of connected devices also, which are being maintained by that, supported by that network. So yeah, that is how I would say. In terms of numbers, I don't know how to count that. Maybe enterprise networks will have maybe thousands of devices, thousands and thousands of devices that are connected. Right. So we would count in those terms.
Got it. Yeah. So that gives us some idea as to when we refer to complex networks as well as
large
networks. So you sort of hinted at traditionally how this management was happening, right? So as a part of our context setting, we also want to little bit maybe delve deeper into that, so that we can then evolve to the core topic of the day, right?
Yeah.
So traditionally, how would you sort of peel that layer off and explain to us that part as well?
Right. So traditionally, networks were being managed manually because they were very small in size and they were static. So the network administrators would actually log into the device and configure the network protocols and network properties and be able to create that network topology, maintain it, keep track of those network topology diagrams, ensure that the network is up and running, maybe have some automated scripts which will scrape the output of text-based commands which you see on your network device. So that is how you get useful information from those devices. So it was a little bit automated, but it was still very manual as well. So that was the traditional way, which was to use the command line interface of the network devices. And then on, a few networking protocols came about. So SNMP was one such protocol, a simple network management protocol, and it came about in late 80s, I think. It worked in a way where it centrally was able to configure these network devices and also monitor these network devices. So there would be a central network management system which would have a SNMP manager, and each of the network devices would have an SNMP agent. So your SNMP manager is querying each of these agents and setting or getting useful information from the network, configuring and monitoring the network in a centralized fashion. So that is how SNMP came about, and it has been one of the most popular network management protocols so far. Even right now, it is being supported by most of the networking vendors. There were some other competitors as well, like CMIP or something, but I think none of them took off really, and SNMP was the key thing to be able to at least monitor the data. And then but it had its issues, and then that's how some other protocols started coming up.
Got it. How was the scaling aspect of these? Because it's trying to query those individual agents, right?
Yes. So scaling was a problem with SNMP monitoring. So how it was monitoring is querying each of the network devices periodically, so one after the other, and then getting all that data and collating, processing it later on. And if you had a larger network, or if your network grew in size, then the granularity at which you can get this data reduces. You cannot have fine-grained data. The periodicity at which you can query these devices increases. So it becomes a scaling problem. And it is also resource intensive for the manager also and for the network devices, because then the network device has to keep answering the queries from this manager again and again, and it puts a burden on that network device also. If there are multiple such management systems, then the resource intensive, it becomes more resource intensive. So it is a scaling issue as far as SNMP monitoring is concerned. It did have other ways of doing things like SNMP traps, which was just push-based, pushing from the device to manager. But since SNMP is UDP based, it is an unreliable protocol. So that's why it was never a good idea to use that methodology. So scaling was a problem with SNMP.
Right. So did they sort of try to, circumvent some of these problems in a way before, some of the more advanced work happened?
Yes. So they did try to solve some of the security issues that I know of. SNMP version 1 had DDoS and DDoS attacks and some other issues also, which they resolved in the version 2 and 3. But this monitoring issue, which I spoke about, they had SNMP traps, which I mentioned. So instead of querying every device, the device themselves would send data periodically to the manager, and this reduced the burden to some extent, because it was able to send the data only on state change or only for the required attributes and so on. But like I said, since it was unreliable, that protocol, UDP protocol, is such that it is going to send that data only once. If it is unsuccessful, it's not going to send it again. That is the shortfall of UDP. Because it is supposed to be fast and not supposed to be that reliable. There are other protocols for that. So that was still a shortcoming with SNMP. So
it's always an interesting trade-off, in some of these systems, right?
Yeah. So the other management or monitoring solutions were REST API based or
Mhm.
XML based. So those were okay as far as how this monitoring or data configuration was also done. But again, it was all very vendor specific. So each of these properties, network properties, is going to be different for every vendor, for every network device. There is a different set of commands for one network switch. There is a different set of commands for the other network switch. So configuring them or monitoring them is also going to be take a lot of effort. So if you were a network administrator, you have to know two sets of commands. If you are a network management system, you have to parse and process and transform both those data to convert it to something which is uniform, which you can really use and show and try to analyze. So that is what was the problem.
I see. So the standardization that you were mentioning, so it was sort of partially, I would say, useful or successful. Is it?
Correct, correct. So SNMP MIB or management information base was a tree-like structure which had a object hierarchy for all the network information. And the object IDs, there were every network property was represented as an object, and it was queried with a number like 1.3.6.7. something, and there were thousands and thousands of such network properties which SNMP was querying. So there was some sort of uniformity and vendor neutrality there, but for the major part of it, every vendor also had vendor specific network properties. Like Arista would have their own MIB, Juniper would have their own MIB, Cisco would have their own MIB. So it was still not completely vendor.
Right. And all of these guys, I mean, all these companies may have some USPs of their solutions and way of doing things, right? So they would want to do some things differently, which is
correct, right? Yes. So they will want to have their extensions and their specific advantages that their product is offering to be private and separate from their key differentiator. So
right. And for good reason. I mean, it would make sense for them to do that. So it's another example of that trade-off that we were mentioning.
Correct.
Good, thanks. I think that paints an interesting background and picture in my mind as well. So we are going to quickly ask our audience an interesting question. Let's see what they think. Yeah, we can flash that one. So which was one of the first local area network technologies? So that's what. Let's jog their memories. Okay, we can see what answers are more popular. All right, so over to you, Manuela. What's the?
I think the ARCnet 1976 was the first one, and ARPANET was more of a wide area technology, which was the first one. So I think ARCnet is the right answer, or at least I believe so.
Right. Thanks everyone for voting. So we sort of went over what was lacking also a little bit, right, in that approach that you were mentioning. You mentioned some trade-offs also. So all of this sort of went on for how long? I mean, historically, if we sort of look at it.
I mean, at least the 80s and 90s, SNMP was quite popular, even the 2000s. And then there were other protocols that came about which were trying to do network management, like netconf and restconf. Like I said, they were based on HTTP, and one of them was based on SSH. And they were trying to kind of solve these problems as well. And then OpenConfig also came later.
Right. Interesting history of this sort of management and always playing with those trade-offs and then trying to solve these problems on ground. So now we can probably turn our attention to, or maybe if you want to sort of consolidate once more for our audience, what was lacking in that approach, and so that you're able to contrast that to the next approach.
Correct. So what was lacking in CLIs is quite evident, that you have to manually go and configure each and every device. You don't have a central way of managing these systems or monitoring these systems. That is what was lacking. And in the SNMP and similar protocols, what was lacking was scalability was an issue with SNMP monitoring, and configurations were also a little tedious with SNMP, even though they were providing a lot of central management of systems. There were private MIBs for every vendor as well. So that is where it was not really vendor neutral. Monitoring was not that scalable. There were some other issues like unreliability of the protocol. So these were the things that were lacking in the traditional approaches.
Got it. So now maybe we can, as you hinted at, OpenConfig, right? So we'll sort of bring that into the picture, and maybe I'll let you elaborate and take us through that thought process also.
Yeah. So after SNMP, other protocols like netconf and restconf came about, and post that OpenConfig also came about. So OpenConfig is a working group of network operators. They are trying to standardize the representation of all this network data into a uniform vendor neutral manner, so that each network vendor can have a uniform way of identifying all these network information. And that is their first goal, is to have vendor neutrality. The other goal that they have is to improve monitoring. And for that, they are supporting telemetry streaming, which is in a way better than the traditional ways of monitoring. So these two aspects are key to what OpenConfig's vision and goals are. There are many big names associated with OpenConfig, many big network operators, and even from other segments of the industry who are contributing to this effort. And over the years, many of the networking giants have adopted OpenConfig as well. Yeah, I think that summarizes it. And OpenConfig also has open source tools and projects which allow implementation of all of this very simply. So if you go to the OpenConfig GitHub, there are many tools that are supported. So if anyone is interested, they can go and check it out, try samples and examples of how these uniform data models can be used and implemented by network vendors.
Perfect. So they have been helping developers and younger companies to put that together. Okay.
Yes.
All right. So one of the key points that you have been making is about the vendor neutrality, right? So maybe could you sort of delve more into that and give us more context on that as well?
Yeah. So vendor neutrality, we already saw that each network vendor has a different command set to configure network, and it is a huge command set because network configurations have numerous protocols and properties that are to be configured on a daily basis, and they are to be maintained. So if you have a different command set for each of the devices, it is going to be very hard to configure and monitor it. That's where these data models or vendor neutral data models come into picture. And OpenConfig is using something called YANG models, which is yet another next generation model. So let me share my screen and show it. Maybe it will become clearer as to how that works.
Sure.
Yeah, so if you can see on the left side here, I have created a block which says LLDP information, which is the switch's neighbor information. One of the vendors represents it as this. These are the properties that it supports. So you have chassis ID, the neighbor's port ID, neighbor's port type, and so on. Whereas the other vendor calls the same property something different. This one calls it port ID, the other one calls it neighbor port. This is how you see that the data is represented differently by each of the vendors. That's where the vendor specific command set comes into picture. And this is being resolved by Yang models. Yang models also have been around since NetConf and RESTConf, and they were created for NetConf, I think. But it is not really tightly coupled with either of them, or it is not tightly coupled with OpenConfig either. It is a generic way of representing network data. OpenConfig has published this diagram that you see on the right-hand side. So these are the models, network information models that OpenConfig is supporting. It is like a tree-like structure, similar to what SNMP also has. So if you see, LLDP is one of the data models. So this is not the end here. This will again have a subtree with more containers and properties under this LLDP information table. So let me show that also. So if you see this LLDP data model, it will have config and state information, then interfaces, under it neighbor information. Under that neighbor, you again have state information, and that's where this port ID is. So you have this whole nested path of reaching a certain property. And they have made it quite uniform across the board, across all those data models. And this can be also represented as a path here. So if you see this down here on the left-hand side, it's called X path for this port ID property. So the same thing that we saw in a tree structure can also be represented a path like this with LLDP interfaces, neighbors, and port ID. So as long as your vendor 1 and vendor 2 are supporting this port ID query with this path, then that is when you have that vendor neutrality, because all vendors have now implemented this data model or this language, which is give a standard way of representing your network information. So that's how this is making it vendor neutral. Along with the property names or the paths, there is more standardization as well. So you can see that each of these properties has a data type. It is either a word or a number. And other than this, there are more things that are supported by Yang models, such as constraints, whether your string is following certain pattern, or if it is a number, does it have minimum and maximum values? So these kind of constraints can also be specified in these data models. And that's where the real power of having uniform data representation comes into picture.
Right. So what sort of an impact did this have on the monitoring aspect?
Right. Yeah. So we are speaking more from the configuration point of view as well, or even from monitoring point of view, because now when you monitor the data, it is going to be very uniform. You don't have to apply transformations anymore. You don't have to get this information and transform into something that is common and then analyze it further. So you already are doing queries for this port ID property, and then you can just collect it very simply on your network management system and then use it. So all this reduced a lot of transformation work that these network management systems would have to do. So that was one way that monitoring was simplified. The other thing was, like I mentioned, the goal of OpenConfig was to support telemetry streaming. What telemetry streaming is a push model. What we saw in SNMP was a pull model, where SNMP managers would keep querying each of the network devices and they would respond. In a push model, the network devices themselves are sending the data on a periodic basis to the management system. Or they are sending some information whenever the state changes. So, or if some port goes down, something bad happens in the system, that's when they would send that data. So there were two ways to send this telemetry data. So that is what improved using telemetry streaming. And furthermore, most telemetry streaming is in a publish subscribe model. So what that means is your network devices are not actually sending to the management system. They are sending that data to a intermediate collector. And this intermediate collector is where this data is being collected and then further sent to the whoever has subscribed to that data. So this removes the burden from both ends, from the management system and from the from the network devices as well. So this publish subscribe model also improved things with telemetry streaming.
Interesting.
So,
I see a I see a parallel same happened in Internet of Things as well. When people move from the traditional SCADA to industrial IoT in a way, right? So it sort of went through this same transition of now using pub/sub models.
okay.
So another question is, so when does this also have an impact on, or does this also improve, expansion of these networks? So onboarding newer devices, maybe in bulk, does it simplify some of that as well?
Onboarding new devices, yes, because you will have a standard way of now doing the initial configuration, but there are some other aspects to it, like network automation and network provisioning, which is initially provisioning your network, which has to be in place too. So only OpenConfig being there is not going to help with that. The intention of OpenConfig is just making your network data representation more standard and your monitoring more standard. Whereas when you are onboarding a device, you want that to be automated as well. Although the OpenConfig does support some interfaces which help with booting your systems or upgrading your systems. So those kind of data models and interfaces are supported by OpenConfig as well. So it did simplify that, but there are other solutions that you need in conjunction with this to have that solution.
Makes sense. Got it. But quite interesting, positives brought about by that. So while this effort was happening, were there any competing, thought processes, or just like OpenConfig, were there some other efforts which may not have panned out?
Yeah, I mean, there are a few others. There is something called OpenTelemetry. I think that is gaining popularity as well. And there must be some other things too, which I'm unaware of. But OpenConfig has gained wide adoption in the last few years, which was not the case in the initial years. The OpenConfig came about in maybe 2015 or 16, but it has been implemented in the last 3-4 years. That all these networking vendors are now supporting it and implementing it, probably using it in their management systems.
Got it. Right. I think a lot of things also go through a bit of a snowballing effect, right? Once some critical mass is reached, then the adoption improves. Good to see the improvements. So along with the telemetry part that you talked of, would you also sort of go into the gNMI part?
Yes, correct. So the vendor neutral data models and monitoring is one aspect, but we need some way to communicate between these management systems and the networking devices. So that's where gNMI comes into picture. It is the gRPC network management interface. So it is providing you that interface, which is giving you the ability to do the get and set of properties, and also the subscribing to that properties so that they are able to stream those. So this gNMI interface has to be mainly implemented by all the vendors, which has those get, set, subscribe functionality or services, so to speak. And those interfaces in turn will get those path properties that we saw. It will get the port ID property using this get interface. It will set that path using set functionality. It will subscribe to that path using the subscribe functionality that this interface provides. So that is what gNMI is. Why it's called gNMI is because it is based on the gRPC protocol or transportation. So the communication between how these requests or get or set calls are going between the network management system and these network devices is through gRPC communication that you see on these arrows. And gRPC is RPC mechanism. It's based on HTTP2 itself. So it's one layer above HTTP, and it's quite fast also. So that's what this gNMI is providing you with. And the subscriptions are also providing telemetry. So that's where gNMI is coming into picture with OpenConfig. OpenConfig is also supporting other protocols like Netconf, RESTconf, but mainly in the recent years, they are promoting gNMI more, gNMI and gRPC.
Got it. So in some of the work that your group is doing, your team is working on, how are you sort of leveraging some of these principles, in your current projects? Of course, without taking any specific names.
Right. So 2 years ago, we did actually work on OpenConfig implementation itself. So for one of the Wi-Fi access points, we created a client application which was implementing the Wi-Fi OpenConfig models and was able to set and get the Wi-Fi properties. So that was pretty good because we got to understand all these terminologies and technologies in a very short span of time. And the way OpenConfig working group has designed all these data models and has created these support tools, we had implemented that client or at least that OpenConfig layer within a matter of weeks. So I think they have a very well thought of, well designed kind of structure for whatever they have been doing, I think. Other aspects which are used are gRPC. gRPC is also widely used everywhere else, not only with OpenConfig. So many networking companies are using gRPC otherwise as well.
Got it. And the support for the development and the developer community that continues to be there and continues to be improved.
Yes, right. So there are groups also where you can go and check. There are many examples which OpenConfig has, many implementations. So gNMI itself can be has code to generate stub codes for multiple languages. So it supports many the clients or servers in multiple languages as well. So I think that is what is the key in the adoption. You have a lot of flexibility in how you can support OpenConfig. So
would you also have maybe to take an example, a sort of quote unquote a real life scenario? Would you be able to sort of give us an example where either you have seen it in your work or an illustrative example where sort of they used OpenConfig and were able to leverage it for benefits?
I mean, the example where we implemented that project is the real life example that I have. But because this is OpenConfig has to be adopted by the network vendor as a whole. So it cannot be done at an individual level. You have to have a networking company who has some network device like a router or a switch, and they are supporting some of these models to be able to use them in the network management system. So that is where OpenConfig can be used. I have not come across many network management systems which are actually using OpenConfig, but many of them have implemented. So I think their corresponding management systems must have some dashboards which are being created from these and being utilized.
Makes sense. Okay. Got it. So we'll do another fun audience poll. So we can flash that one now. Yeah. So this one is, what is the number of devices connected to the internet as of this year? So just a rough scale, I guess. That's what you're looking for. Okay, yeah, let's see what the audience thinks. Did they get it right?
That's the right answer. Even I got it from a Google search, so maybe that's what everyone could have done.
Good. Thanks for playing, guys. So Manuela, so thanks for sort of elaborating on all these different aspects. So I think what I want to ask is, you have been in this area for a long time now, and you have looked at OpenConfig specifically also very closely. So as you see those current developments and stuff that is coming up, right? So how do you look at these further developments, and what do you see as the new excitement is there, as well as what may be some of the pitfalls, or what challenges may be there?
Right. So the challenges or pitfalls are, maybe I'll speak first about it. Adoption was key for OpenConfig. Otherwise, there is no vendor neutrality. So even if you have a few vendors who are not moving to OpenConfig, then you still don't have that neutrality. You still have vendor-specific ways of querying, and that's why that was important. But that has happened over the years. But the challenge is going to be, as soon as there's something else which is better than OpenConfig, everybody is going to be moving to that. So it is to be seen whether this is here to stay, or if something better is going to replace it. Overall, I think OpenConfig will keep evolving or support more data models in general. So I think because it is a good standardization. And as far as the future is concerned, for OpenConfig, I already said, but for network management as a whole, I think that the term that the networking companies are now using is network uh, observability. So which is a even broader term. It's more than network management. So what you have is your telemetry monitoring, and along with that you have a data platform which is analyzing and giving you insights into your data as to how is your network really performing. uh, are there any optimizations that you could, so there is use of machine learning also, where you could learn from what has been the traffic patterns of your network and how the network could improve the network performance, or gaining other insights. So I think AI will be the future of network management, and it is already happening. Cisco and Arista and other companies also have their AI platforms which are kind of doing network management, monitoring, and getting into these areas. So I think that would be the future, if not OpenConfig necessity.
Yeah, that's quite. It will be interesting to look forward to that and see where that goes. So maybe a little bit less relevant question, but let me still ask. So how do you look at two aspects which pop in my mind? One is about the failure of some of these devices, some redundancy which maybe need to be built in, and then secondly, there may be scenarios where for whatever resource constraints reasons, connectivity is a little bit intermittent. Are there scenarios like that, and how do they deal with it? Either it is directly along with OpenConfig relevant to that, or maybe separate. But I think if you
All right. Yeah, it is probably separate from OpenConfig, but yes, it is an important aspect of monitoring and managing your network, because you always want to have a network which is always available. So if there are any faults happening, redundancy is the way to do it. You have backup devices, or you have a whole the network architecture is, you know, fully connected network, so that if one of the backbone or if one of the switches goes down, then there is a different path that your traffic is going to take. So that redundancy is always built into networks, especially the larger networks where you cannot have any failures or any drop in traffic. So I think that has always been the case, but it is more on the side of how your networks are configured, rather than centralized management or centralized visibility of your network. Yeah.
Understood. We have one audience question which has come in. So I think you touched on the AI aspect, right? So that's what they're asking about. So is OpenConfig community, are they doubling down on AI? That's the question.
I don't know about that. So,
but you probably see some indication that they want to enable that more, or are they going deeper into that?
Not really. I mean, at least from the OpenConfig website, there is no indication of whether they are going to get into that space, because it is more for standardizing things rather than uh, it's not it's a working group which is providing you standard models and standard ways of doing things, whereas you cannot have any standardization in AI, I think.
That way, yeah.
I am not the right person to speak about AI at all, but probably this is the job of each network vendor to have their own algorithms to be able to uh, provide those kinds of insight, because it is very vendor specific naturally. You have different types of network devices, and you are going to look for different things from it. So it depends on every network vendor to be able to support that, I think.
Interesting. So with one aspect, we have taken care of the, we have brought in neutrality and made whatever was common has been sort of taken care of. And then the other aspect is going to be what they each decide to do with it.
Yes.
And
Correct. That's what I think. I mean, once you have AI in picture, this standardization would not even be required, because your AI might be taking care of doing those translations which were a problem before. They are going to understand all these command sets and be able to transform them automatically to whatever you want, and then analyze them even if the data is heterogeneous, I think. So this standardization may not even be required.
yeah, there are quite fascinating waves of innovation which may keep coming, and it remains to be seen how they either disrupt or improve what is going on. Thanks. So I think probably no more questions as of now that I see from the audience. So yeah, thanks Manuela for taking us through this journey. Quite a fascinating topic. You made a very technical topic, accessible to all of us. So thanks for that, and thanks everyone for joining. Please check out our page and watch the YouTube channel space for all our episodes in Everything Product Series. We keep publishing those videos periodically, as so this will be available to watch as a recording later on as well. So thanks everyone for joining us today, and have a good day forward. Thanks.
Thank you.